Prove the statement for any integer n square minus n minus 1 is always odd. Hence prove that n square minus n minus 2 whole cubed is always even. So to work it out, we use proof by exhaustion. So let's say I'm going to write it down. Use proof by exhaustion. So as a first case, let n be odd. Then n can be written as so we can write n as it's an odd number, so do twice of a plus 1, and therefore n square minus n minus 1 can be written as, instead of n you write 2a plus 1, so 2a plus 1 whole square minus of 2a plus 1 minus 1, and that equals 4a square plus 4a plus 1 minus 2a minus 1 minus 1, and that equals 4a square plus 2a, and the plus 1 and minus 1 go away. We are left with minus 1. So if you were to take 2 outside the bracket, because we have to prove that n is odd. So to prove the oddity, we first have to say it's a multiple of 2 and add 1. It'll be 2 times 2a square plus a. That would give you 4a square plus 2a, yes. And then, now I missed a step. Wait, you can rewrite this as, before that, 4a square plus 2a. You write minus 2 plus 1. So if you did that, then you can write this here as minus 1. So, and then you can write the plus 1 separately. So this is odd. Which is odd? Odd because it's a multiple of 2 plus 1. So that is even, plus odd gives you odd. Multiple of 2 is always even. So we have proven the first case, that is when n is odd. Now for the second part, let us say let n be even. So let n be even. Then n can be written as 2b, can be written as 2b. So therefore you can write n square minus n minus 1 as equal to n square, then you put 2b square minus 2b minus 1, and that is 4b square minus 2b minus 1, and that equals 2 outside the bracket, and you can say that would be, or we can do it again once more like that. We can say that would be 4b square minus 2b minus 2, and then plus 1. So keeping it in the same way, Or we could have done it as -1 as well, taking 2 outside the bracket, because odd, even minus odd would be odd. So if we have this, we have 2 outside, that would be 2b square minus b minus 1. So I'll make it 4b square minus 2b. Yes, that's right. And then I do a +1. So it means again which is odd. So once again it's even plus odd equals odd. So you've proven the two cases, the one with even and also the one with odd. So therefore the first part of our proof is complete. So this completes the first part of our proof. The second part, that is n square minus n minus 2 whole cube, is always even. You see, n square, I use a different color. So then I can say n square minus n minus 2 can be written as n square minus n minus 1 and minus 1. So we've already proven that n square minus n minus 1 is always odd. So I can write n square minus n minus 1 is always odd, proven. So not so. So you can say and odd minus 1 equals even. So if you take 1 away from an odd number, you would get an even number. So it, you can write that. So once we get that, therefore this number n square minus n minus 2 is even. Yeah, might as well. So one, I should say, instead of 1 I can always say odd, like, or maybe we keep it like that. Okay, so then we can say that n square minus n minus 1, n square minus n minus 2. So n square minus n minus 2 is even. That proves that n square minus n minus 2 is even, and even multiplied by even would be even. So if n square minus n minus 2 is even, n square minus n minus 2 square would also be even, cubed would also be even, any power, because it's always being multiplied by another even number, and even times even would always give you even. So therefore n square minus n minus 2, and if I were to write cube, is even. I think we did the proof.